somehow. Okay, let's see. Right, let me start. Sergey and Ed, thanks for joining. Yeah, so just to give some context where we are currently with the CAP, I don't know if you all are familiar with the attribute-based API. So we were discussing how to bring that in Kubernetes through some sort of if we could leverage some of the resource claim mechanisms available with DRA, or how we can extend that. This gives a short example which we used in the past, how such kind of attribute-based request or resources, CPU resources, can look like. So you have standard kind of claim kind of mechanism from DRA. In our kind of prototype, for which I have a demo today, we started just with simple JSON format in the config maps. Basically, what you see is some sort of set of cores. Usually, those set of cores define pools. Basically, it means you want to request a small pool of 2 cores, which is exclusive, with some basically also requiring that they end on the same siblings, maybe some frequency. Then another 6 exclusive cores without additional configuration, or 4 shared cores, just to give an example how this is interpreted. This was our first iteration, how such a JSON thing can look like, and we worked in the last days to give a little bit more detail about possible API. So we were thinking to have basically first some sort of identifiers at the beginning with which you can easily identify the pools, usually similar to DRA. You can use those in resource classes and assign them to containers quite easily. So basically, you give some IDs for each kind of pool. Then the other thing, what we were wondering if it would make sense, is to add some sort of capacities, so that we can pre-allocate those pools in a static way, something similar to if you think about the static policy. Then we could predefine those pools, and they will not change over time. And basically, when you are claiming some set of cores, the pools will get reduced over time, and at some point, user will get error if you run out of resources. This was one possibility which we are considering if such kind of capacity would make sense, because we are also thinking when we are pulling out resources, there are several ways how to do it. We could do some sort of, if you are in the case that you want to pull exclusive resources, usually those are pinned. So you will, if you are requesting an exclusive resource, in most of the cases you don't want you want the full control over the core or the logical cores. That's why something like guaranteed QS is very close to that kind of wish. So basically, we could do the first 2 cases here are exclusive, exactly 2 cores. Or let's say we want an exclusive with some sort of burst between 6 and 8. But in that case, the CPU set, what we want to allocate, we have several possibilities. We can widen out the CPU set to 20 cores and fix basically the CPU shares so that they fit this kind of range. Or we could, in exclusive kind of type, we could limit it to 8 cores. Basically, the CPU set is max 8 cores, and then basically it can burst between 6 and 8, dependent on the application. And the most interesting case is the shared, where in that case we again define a range. But there are multiple ways how you could deal with shared. Again, this could be limited just to a CPU set of 4 cores, or we could limit it to the complete 80 cores and give CPU shares so that they can work on the 80 cores. The idea of the shared pool is basically you can put any kind of pod which requests shared resource on that. Exclusive resource, you cannot put other resources on it. They are not shared, so they will be not allowed to overlap. And yeah, that was roughly what we were thinking.
How do you know that this 1 to 4 is shared and 6 to 8 is exclusive?
The order currently gives it the information. So we assume, or we are defining the maps or the JSON in a way that it should have the same cardinality, this list basically. It has always the cardinality of 3 all across the JSON. So basically, if you look to the third place of the list, it corresponds to the you can find out the CPU attributes for it. It's basically matching shared. So the position in the list gives us codes all across the list, more or less.
And I didn't quite understand what the pool means. Pool is it something that we expect machine to have, or
It's the request. Basically, you are requesting a pool. This was just something which we wanted to throw in the conversation today, if such kind of capacity would make sense. So originally we were thinking just to claim cores based on the available resources on the machine. But we could also define some sort of capacities. So we could pre-allocate a pool and then start pulling out of the pool. But if there are not enough cores on a certain system to handle this pool request, it will fail. Right. So the pool is the upper limit. So your shared cores can be, or you can use max 80 cores as shared. Then you have 10 and 20 of the other two cases.
and is this what pod will define, or it's configuration across the node?
This is part of the claim. So basically, it's defined in this JSON configuration map, which is attached to the resource claim, right?
I see. Okay.
The other kind of aspects which we were considering to add to the spec is how to control NUMA. We have use cases where we need NUMA device affinity, basically network affinity and stuff like that. So we were thinking to define that as some sort of close to a binary condition. As usually the NUMA device will be picked by another plugin or by another system, let's say device plugin or a DRA plugin. We could require this stuff will be executed after the device was picked, and we could require basically we want the device NUMA affinity to the selected device. We prefer, let's say, it's good to have NUMA affinity to a selected device, but it's not a must. And then we don't care, something like this kind of options. And we were thinking similar for memory affinity. Memory affinity, basically pointing back to memory controllers. So basically, we were thinking to have in more like kernel style definition manner. Bind required means basically that you require to be on this to be on the same socket as the memory controller what you need. So bind preferred, so you try, but it's not a must. And then we have something which corresponds a little bit to today's NUMA spread options. If you think about topology manager, it's interleaving, basically, that you can interleave memory controllers, right? And then we might need additional parameters later for huge page handling, and so on, right? Any
So
question?
Sasha was telling me about this scenario when some modern hardware has this memory that kind of bound to two nodes. So I understand that we have some oversimplified model right now with CPU manager, topology manager, and memory manager. And you trying to go one step forward here, right? So a little bit more involved, like you're trying to describe every single pool and like how much out of this pool we take and how to bind resources. I wonder if it will cover all the hardware, or like next step will be we need completely different model because hardware changed.
We might need to extend it over time. I think the idea is to cover at least hardware which is coming in the next several years. At least also, if you read further, we want to deal with core siblings and cluster siblings. So they are right. We are thinking according to trying to cover the needs of hardware coming in the next, I don't know, let's say 3 to 5 years scope.
Okay, so there will be some versioning.
There should be some versioning of that stuff, more stuff coming in over time. So I think we have to version it, yes. Just
and those details will be exposed to cluster admin. So cluster admin will like, is it something that can be auto discovered out of the machine, or it should be something that driver will know how to be configured? I still quite not like
how it's discovered.
I thought this meeting is about like plugins for Kubelet, and like I think you already made 3 steps forward, and unfortunately I still catching up. So maybe it will help if you can explain more, like how this file being created, like who is responsible for that?
Yeah, so this is responsibility of the user. The only thing which we are not sure if it's a user responsibility is this capacity pool thing. So theoretically, this can be moved out, or it's something which is not needed. But all the other options, we see it as responsibility of the user. Usually it's, that user wants his application to be affinitized close with the device, or he wants an exclusive core or a shared core, right? Or even both in a set of containers, right?
Okay, so and yeah, so user will declare that. Yeah, this capacity doesn't fit in my mental model. Like I was really confused.
That's why optional currently. The reason for the capacity is if we want to how we deal with this kind of burstable classes, more or less. If you have something like burstable, if you think about standard burstable and best effort pods and containers currently in Kubernetes, you get the full CPU set of available resources on the system. So to guarantee that we have an exclusive course, we need something like dynamic policy, more or less. We will need to squeeze down over time this kind of burstable and best effort cases. And that's why we were thinking such kind of capacity can help us start smaller with a static kind of pre-booked resources. But or the other way around this, if you have a shared pool and such kind of burstable definition, we limit it to 4. this will work too. So you will get a CPU set of 4 cores, and you burst between 1 and 4 on that. So you can guarantee that your exclusive cores will end on another CPU set, which will not overlap. That's the reason, more or less. But yeah, we were also discussing internally, maybe this doesn't fit in the user model a little bit, the capacity, right?
I don't know how many more slides do you have, but I really want to test some scenario on this and if it fits this model. So somebody came up with scenario saying it's really about sidecars. So if you have a job that is really CPU intensive, it wants exclusive cores, it wants some NUMA affinity, it wants to be executed really fast, and it knows what it wants. But then you also want to run some metrics sidecar on the same pod that will report that it's still alive and like maybe report on CPU, like some metrics like how much things were processed and stuff like that. And you don't really care about this metrics thingy because this metrics container, it can run on shared CPUs for all you know. Like you don't care about it. Like you just need some resources for it to run. Can it be expressed like this resource claim will look like? I mean, it will. Can this resource claim be used to express the scenario?
Yeah, so you could basically your performance stuff. Let's say if we want to, I can write here. So basically, let's say your performance stuff, you have two, one for the sidecar and one for the main app. So your main app, let's say it wants, I don't know how many cores, maybe 2. So you will get 2 pinned cores, and then let's say you want, you have the sidecar. Maybe the sidecar, if it uses just 1 core, you define one core for the shared pool. So it ends on a different CPU set. If your sidecar, it's some sort of burstable thing, maybe you can define 1 to 5 cores. Right. The question now is, we have several possibilities how to deal with the burstable case. We can limit it through capacity, or we can limit it based on the available CPUs on the platform. So, right, if your platform, let's say, had originally 40 cores, we can take out 2 for your exclusive fast container, and we can give the rest of CPUs as a CPU set, basically for your sidecar and with this kind of CPU share.
Okay.
That's the idea, more or less what we are going.
And how do you mark your containers to use those cores?
The containers usually in the yeah, you see here, you have to specify in your container what you want to claim. Okay, most probably the names are a little bit wrong. So you can specify in resources a claim. So this is how you point to your claim. Usually the template has the name, so this should be resource. So, and then additionally, you have other options in this stuff. You can specify. So you see that it's per container. You have the claim, but there is also another option to inside the claims to specify resource class. I think it was called. It's part of the array spec. Resource class.
And it will be named thing from next slide, right?
It will be basically the ID. Let's say your E2 is the fast thing. You want this container to be the fast stuff. It will be E2, and then your sidecar is basically S5, let's say, just as an example, right? So if this was the, okay, in this case was a second container without claim, but if you had a container with claiming again the resource stuff, you could specify after that another resource class, and let's say basically the shared resource class, and we will know to pull in to consider basically the second element of the allocation kind of attribute list for your container.
Okay. And we'll cover Derek's scenario. Derek was asking about scenario when all system pods needs to be like system and static pods needs to be assigned to a specific set of cores, and all the rest of the cores needs to be assigned to like workload pods. Is it something that can be expressed here, or it doesn't cover the scenario?
The system resources we were thinking to handle similar to how they are handled today. So you have reserved CPUs, you define them by kubelet configuration, and then they are removed out of the set basically as not non-available CPUs. So basically we will take the standard mechanism, how you define system resources as you have it today, and forward it to our manager and and remove them from the set of available resources. Just to maybe to give it as an illustration, I have this kind of picture. Let's say if you had available resources, I will paint it a little bit. So you said when starting kubelet, I want two cores. So 2 cores to be system resources, as we do it today in kubelet. We will read this configuration through the new manager, through the CCI manager, and remove them. So what our manager knows at any time how many available resources we have. So if you started with system resources, 2 cores, so basically the initial set will be 8. 8 shared cores, 8 exclusive cores, basically. And you get four pairs for hyperthreads, for hyperthreading pairs, more or less. That's at least the approach of what I was thinking to start with, just similar to the current configuration what we have. That we don't do it, don't give the it's more administrator kind of configuration, and we make sure that we take it into account.
Okay, and if you want to schedule pods on this reserved CPUs,
you cannot currently.
You cannot.
Right.
I think that was a scenario that Derek wanted to investigate. I think they're doing it through Cryo right now. So Cryo has this way to pin system pods on specific CPUs, and don't.
You want to pin the but this is what, or they will be pinned more or less to usually, like, yeah, if you specify reserved CPUs 2, we will give the first 2 cores basically on the system or something. Yeah.
You may want to specify which cores too, Thomas. So
yeah, I think, yeah. Or I don't know. Usually the way how it was done before, it was just counts. But I don't know if you can, if it makes sense to configure which cores. Maybe it makes sense to configure that you want them on both sockets or something. But yeah, as it is administrator kind of configuration, we might think about it. But
yeah. And mostly I'm asking you. Yeah, go ahead, Anna.
Sorry. So, I think it is relevant to say, wait, who owns that piece? So whether or not we want to continue to do it through Cryo, or if Derek would like us to do it through these plugins and just send over the information. But the information may include which NUMA zone and what type of core. So if we're talking about cases where architectures are coming up with a combo of efficiency and performance.
But just to understand, Derek wants to run some pods in a later time frame, which have to go to the system cores. Is this the request, more or less? Or
I think, and again, I will explain why I asking about it from my perspective. I think what Derek scenario is that all the systems, like they run a lot of daemons and some static pods, and they want to make sure that those static and daemons only occupy specific pool of CPUs, and they don't try to execute on any other CPU. So all other CPUs are allocated for workload. So their customers would know that those CPUs are not accounted for any workload, and everything else is workload exclusive. So no system pods will be running on those.
That's the goal. We would also like basically to subtract them away from the sets of available resources for applications. So we have to figure out how, if we still use the previous mechanisms to define them, to configure them, or we have another one.
Yeah, and I'm asking this question because I want to understand, is this cap limiting to this is what I want, please figure out how to give me that, versus like you also specify, like there is also component of it that you know how system looks like and you know how your request will map into actual system, and maybe like scheduler will even know like whether your workload will fit into the system or not fit into the system, and it can be done universally.
Well, user will not know the system, let's say, but user will know what he wants. User will know that, let's say, my application is memory bound. In that case, it's good to spread across all memory controllers. So user will specify that, and let's say user knows that my application needs to be pinned. And then also, the spreading of controllers. So it's more not really knowing the hardware, but knowing the nature of the application. And then requesting the right, or giving a request which should find the hardware which fits the needs. Right.
Okay. Yeah,
right.
I think I followed.
That's what we are after. So then we had also in the previous meeting, we went a little bit through some architecture decisions. We got currently we are considering basically the idea is to have a new manager, the CCI manager, which can understand DRA requests or basically claims. We will reuse completely the controller components provided by DRA, so we can recreate or use the same API to create controllers to handle the scheduling pieces. And then originally we were thinking to have still a node driver which handles the reservation of claims. But as discussed today, basically Kevin was suggesting we don't need that piece. We can actually implement everything in one component. So we could implement the reservation kind of handlers inside the CCI handler. The CCI handler is the one which the CCI manager will call. So basically, our kind of handler for allocating the claims will be completely independent from the node driver. We will not need a node driver. We will just reuse the controller and the resource class. The resource class allows us basically to basically process pods which have claims. So we are applying the driver only on the pods having a resource class with a driver name, with the right driver name. I will show that we have it in the prototype. Basically, it's the same mechanism like in DRA, where your kind of resource claim it's basically somehow mapped to a driver. So this is one-to-one, basically similar for us. Then suggestion from Kevin from NVIDIA was if we can get rid or if we can handle or make our CCI component on the driver side being able to handle the whole thing without additional node driver. So he was suggesting that we have one single component independent from the DRA node driver, which implements the logic which we need to handle the location or even the reservation of the resource requests, as they are a little bit different compared to the resource requests what you have for devices. This will allow us to nicely split them away from the original DRA, which is more for devices.
The config file you showed
Mhm.
looks very generic. Like it looks at why do you need a specific driver for that? Do you have a sense like why it's not like it looks like a policy for a CPU manager or like topology manager more.
It's like a remote policy. The driver actually it's helping that you could handle a set of pods, not all. So you could still run other pods through the standard CCI manager without going through driver. This is one of the benefits of the driver, but also another kind of benefit is you can do similar kind of claim, or you can, the benefit of the driver is from scheduling perspective. If you have this kind of complex or attribute set, how do you schedule it? Becomes the question, because if you think about standard pods, you have the scheduler, which runs a scoring algorithm. So if the pod has basically a resource requests and limits, the scoring algorithm will start filtering nodes. So this is where the driver, together with a controller component, takes over on the scheduling side. So, or it helps on the scheduling side determine the right node. The condition here is basically that the pod using these claims, similar to the example, does not have any kind of limits. And you see in the resources, I'm not adding resource limits and resource requests, as they are considered by scheduler usually. So if I add those, the scheduler will score the pods or according to requests and the nodes. So we could avoid that in alpha version by keeping them more or less best effort, not having that, and basically a scheduling decision is taken by the controller. So further kind of optimization on the scheduler side, most probably it's possible, but we will think about it in little bit in beta phase if we can do some scheduler processing of claims and stuff like that. So this is still to be investigated. But I think for a start, we could basically rely or require that such kind of pods having a CPU claims, more or less they don't should not provide, or if you provide request limits and so on, then the scheduling can further limit the set of nodes. Because usually DRA controller, if you think about DRA controller, it's run after scheduling. So if you did the scoring before that, the controller might have already less nodes available to schedule to.
Yeah, it will be interesting how like there is a lot of tooling relying on requests and limits. So
Right.
it will be interesting for this tooling to adapt to understand this resource claims.
Mm-hmm.
But if you go back to your spec, just so I can make something over.
We
We
can,
both hear you, Marla.
yeah,
Can you not hear me? Okay. Can you now?
yeah,
But-
it is.
Okay. I have to sit up straight. If you can you go back to your spec on the CPTK user IO syntax?
Yep. This one, you mean?
Yeah.
Or
So I know this seems very generic, Sergey, but I want you to think that we have, for instance, performance cores coming out versus efficiency cores and stuff going forward. So when you look at those CPU attributes, I know right now we just have exclusive and shared, but because there's all the different cores coming out for sustainability reasons, we need to be able to handle those, right? Does that make
yeah,
sense?
this will be another attribute. We will have core types, most probably in the future.
Because the other thing that you run into with users is they want some number of cores, but they don't necessarily know what they're running on. So if you're using a very large heterogeneous cluster and you're just getting scheduled, 4 cores for like a 1.5 gigahertz is going to be very different than, you know, a 3+ gigahertz. chip.
So you're saying that those attributes would be driver specific, or they will be single driver covering everything? You just want to develop the driver faster.
You can do either, right? So you could have drivers, like you could foresee having drivers that are scheduled on just your types, you know, your chip 1 types, right? And those drivers were only installed there, and then your drivers scheduled also on, you know, your chip 2 types, right? And so when you do the scheduling, it looks for, so if we're just doing exclusive and shared, and we don't care, you get scheduled anywhere, and then your driver handles it. Otherwise, you're going to have to get scheduled only to those nodes that have the available attributes.
Okay. Yeah, I think I understand the reasoning. My comment still stands. Like there are tooling that looks at requests and limits, including monitoring and such. And it will be interesting how those pods will be handled and whether we need to do something to satisfy that. Maybe some calculated requests and limits will be needed.
Yeah, it's possible. But
Yeah.
we'll do some testing and see if we hit a wall.
You mean also calculation on scheduler side for the future? Or
I don't know. Like, yeah, it's. I don't know a specific scenario. It may be if customers just monitor like bin packing of their nodes, they may have troubles not having requests and limits on specific pods because they calculate this bin packing using those fields, and not having these fields will require them to change the tooling, or like their tooling will be confused by that.
the monitoring mechanisms. Yeah.
Bin packing of pods will be maybe affected. Okay. Yeah.
Yeah, so that's more or less what we had from slide perspective. We have 10 minutes maybe for a short demo, if this is fine, or some further questions.
Yeah, I have a question. So how scheduler would know that it shouldn't schedule workloads that actually like don't reference any claims to that node, which is like under control of this CCI manager?
So the nodes or the kind of pod can be scheduled on that node. It can go. But what we should make sure is that after that, if the pod goes and consumes resources, we have to take that into account. So we have to subtract the resources, but we are not rejecting scheduling pods on that node because it runs the CCI manager. To the contrary, we allow it, but we just take that into account. So basically, if you schedule a normal burstable container, it goes through, but we want to make sure that later, if we put an exclusive container, they don't overlap, right?
Yeah, so that would require some kind of communication between CCI manager and CPU manager and memory manager, right?
Not really, at least in alpha version, the CPU manager is disabled, it's running non-policy, so we take over. Basically, the CCI manager will be responsible to basically define the CPU set of this kind of pods, incoming pods, which are not handled by driver.
Okay, so it will be handling like everything. So those pods that actually require some CPU and memory sources, and as well pods that reference claims, right?
Correct. The goal would be later in beta if we can maximize code reuse. So there is a lot of code already available to handle the standard cases, the static CPU management and so on. Maybe we can stage out some of the code, make it available also for the CCI manager so that we can just instantiate certain kind of type which does that for us. We will be looking into that.
Okay, that's more or less clear. Thank you. And the next question is, can you go like back to this sort of slide, the control plane development kit?
Yeah, this one?
No, not this one. It was the picture.
Oh, yeah. Okay.
Yeah, this one. So it's still not very clear to me, like this thread 1 and thread 2. So can you elaborate a little bit?
Yeah, this was the original idea. Now we are changing that. Thread 2 will disappear. We were thinking to use the controller. We required the node driver. But our thinking was wrong after discussing that with Kevin. He suggested that we get rid of the first thread and basically implement the handling for all what we need to allocate the claim inside the CCI handler, make it basically standalone. Right, thread 1 will go away, more or less.
And how Kubelet would distinguish between two types of pods, those that reference DRA claims and those that reference the CCI claims?
Through basically driver name. So you hopefully you don't have the same driver. And additionally, there's the driver name, and the second thing is we use another socket. So we usually for DRA you have varlib DRA kind of socket to do the registration. We will do a varlib CCI to handle the registration separately, and they don't get mixed. So this is the idea. Right?
Yeah. Okay. Now I understood. Okay. Thank you.
No problem.
Does Kevin envision any collaboration between DRA and like this driver? Do we need to schedule assuming both?
I saw from him some sort of future cap where he could allow multiple controllers somehow to communicate or to take joint decisions. Maybe it would be interesting in the future to make joint decisions on the controller side if you have some devices into play. So this is something which I would we might have also some use of it. Because we will need the device affinity informations. So I think this future cap with multiple controllers, he was pointing to that it could deal with some of the topology management challenges, what are currently there in this future concept. So most probably there is some place for collaboration there, I guess.
And this collaboration is happening in Kubelet architecturally or in a plugin? Driver.
I think it will be, as he has a cap for that, I assume he needs to add something to Kubelet before that. I'm not completely deep in his cap, how to support multiple controllers, but I assume there is some change still needed.
Okay. Yeah. I mean, to be honest, completely honest about it, I can give a lot of feedback on like how architecturally put like different components in different places. My biggest problem is I don't know all the scenarios that people may need with regards to like I want to schedule it this way, but then I want to do this like energy efficient view, and I want this device to be very close to me. So I don't know these scenarios. Like any help you can provide on highlighting those scenarios are important. Those scenarios will not be covered, but we don't care. Will really play a big role here. Like I would really appreciate having this overview, like what is supported, what we are cutting out of support explicitly. So this will help understand whether like like design choices that we make. Because
Yeah.
I can point on like this may not be working for this kind of scenario, but I have no idea whether how important the scenario. I will definitely ask around on my side, but like if you already know that it's not important, like you can list
For
them.
some scenarios.
Um,
Yeah, maybe we can think about having some section in the cap listing some of the scenarios which can run with it and which are limited somehow.
Yeah, we absolutely should put that in there. Because some of it has to do with the fact that we're looking at both performance and sustainability. We both come from HPC type backgrounds, so we've seen a lot of what those look like that we don't handle in Kubernetes necessarily. But yeah, that one of the, and maybe we should add in the stated goals of still minimize pain on the user as far as understanding system architecture, because HPC classically, the user has to understand the architecture. We don't want to do that in Kubernetes.
yeah, for instance, one problem that somebody told me about is topology manager doing wrong decisions in terms of like it picks up wrong NUMA first, and then it cannot schedule anything else because like it's already took half of resources of like big NUMA node, and like nothing can be scheduled there any longer. So I don't think we address this scenario in any sense right now because we don't know about future pods that will be scheduled. So we're cutting it out, but I do realize that we're addressing other scenarios, and this scenario of proper scheduling may be delivered later.
Yeah, scheduling is here a little bit left to the controller writer. So if the way how, or if also this future cap for the multiple controller stuff is in place, yeah, I think it becomes important how the controllers handle this kind of decision making after that. So it's a little bit externalized in that case, the decision about the scheduling.
Okay. Thank you very much for presentation. I think I don't think I will see anything new in demo, so maybe I will just watch recording.
Okay, no worries.
Thank you.
Right. Thank you.
Bye.
Thank you.
Thank you. Bye.
So, bye.